Bachcho, in this question, a current of 4.8 amperes is given to us, and we have to find the number of electrons crossing a cross section per second. Now, my dear bachcha log, current is given by the formula I is equal to charge crossing per unit time. And beta, in electrostatics we learned that any charge will always be an integer multiple of E, where E is the charge of an electron. So from that beta, I can just write I is equal to NE by T. If I substitute the values, my dear bachcho, in this question the current is given as 4.8, number of electrons I'll just write as N, charge of an electron beta is 1.6 into 10 power minus 19, and beta, they are asking us the number of electrons crossing per second, so I will take time as 1 second, or just 1. From this beta, N will become 4.8 by 1.6 into 10 raised to the power 19, which will become 3 into 10 raised to the power 19. So option A is the correct answer. In this question, if the electronic charge is 1.6 into 10 power minus 19 coulomb, then the number of electrons passing through a section of wire per second when a wire carries a current of 2 ampere is what? So beta, once again we will use I is equal to Q by T. Current is equal to charge crossing per unit time, and charge as a number of electrons into charge of 1 electron. So substituting the value, I is equal to NE by T. Now we will again just substitute the values. I will write 2 is equal to N into 1.6 into 10 power minus 19, and here also beta, we have to calculate the number of electrons passing per second. So time period will just be 1 second, which gives me N is equal to 2 divided by 1.6 into 10 raised to the power 19. That will be beta approximately 1.25 into 10 raised to the power 19. Option C. In this question, my dear bachcha log, there is a non-conducting wire of a radius r, which has charge q distributed unevenly over it. It is rotated with an angular velocity of omega. Then we have to find the equivalent current. So my dear bachcha log, it is rotated with an angular velocity omega. Now here once again beta, I will say that current will just be equal to charge crossing per unit time. Now my dear bachcho, if I talk about one full rotation, the charge crossing will just be equal to Q, because in one full rotation the amount of charge that will cross a cross section will be Q. And beta, the time taken for one full cross section, you have to know my dear bachcha log, that time taken angular velocity is equal to angular displacement per unit time. Now for one full rotation beta, I will write down angular velocity as omega, angular displacement as 2 pi radians, and time as t, which gives me t is equal to 2 pi by omega. So I will substitute 2 pi by omega here, which gives me bachcho I is equal to q omega by 2 pi, which is option C. In this question beta, the current flowing through a wire depends on time as I is equal to 3t square plus 2t plus 5. We have to find the charge flowing through the cross section of the wire from t is equal to 0 to 2 is equal to 2 seconds. So we will write, my dear bachcha log, I as equal to dq by dt, the rate of flow of charge, which gives me dq by dt is equal to 3t square plus 2t plus 5. Now my dear bachcho, if I cross multiply, I will get dq is equal to 3t square dt plus 2t dt plus 5 dt. Now if I want to calculate the charge crossing beta, I will just integrate this. When I integrate this, my dear bachcha log, I will substitute the limits from 0 to 2 seconds, which gives me q is equal to 3 into 2 cube by 3 plus 2 into 2 square by 2 plus 5 into 2, which gives me q is equal to 8 plus 4 plus 10. That will be equal to 22 coulombs. So option A will be the correct answer. In this question, a conducting wire of cross-sectional area 1 centimeter square has 3 into 10 raised to the power 23 charge carriers per meter cube. If the wire carries a current of 24 milliamperes, then the drift velocity of the carriers is what? So, my dear bachcha log, here what I will just say is that current I is given by the formula I is equal to NEA VD. So in order to calculate the drift velocity, I will just rearrange the terms. Vd will be equal to I upon N into E into A. Now according to the question beta, the current is 24 milliamperes. That is 10 power minus 3. Milli is 10 power minus 3. Divided by beta, number of free electrons per unit volume is 3 into 10 raised to the power 23. Charge of an electron is 1.6 into 10 raised to the power minus 19, and area of cross section is 1 into 10 power minus 4. Remember beta, 1 centimeter is 10 power minus 2 meter. So 1 centimeter square will be 10 raised to the power minus 4 meter square. When you square the terms beta, you will get 10 power minus 4. Now this will become beta 8 divided by 1.6 into 10 raised to the power minus 3 minus 23 plus 19 plus 4. Yeah, that will just become, my dear bachcha log, 5 into 10 raised to the power minus 3 meters per second, which is option C. In this question, my dear bachcha log, at room temperature, copper has a free electron density of 8.4 into 10 raised to the power 28 per meter cube. The electron drift velocity in a copper conductor of cross-sectional area 10 power minus 6 meter square carrying a current of 5.4 ampere will be what? So my dear bachcha log, once again we will use the formula I is equal to NEA VD, which gives me drift velocity Vd is equal to I by NEA. Substituting the values beta, we will have 5.4 in the numerator. The number of free electrons per unit volume is 8.4 into 10 raised to the power 28. The charge of an electron is 1.6 into 10 power minus 19, and area of cross section is just 10 power minus 6. Now beta, this will just become, if you see, 84 is divisible by 21. If you do the calculation, my dear bachcha log, please don't make me do the calculation, but if you do the calculation, it will become 0.4 into 10 raised to the power minus 28 plus 19 plus 6. That will be equal to, my dear bachcha log, 0.4 into 10 raised to the power 19 plus 6 is 25. 10 raised to the power minus 3 meters per second. That is 0.4 millimeters per second, which means option D is the correct answer. Next is beta, the mobility of free electrons in a metal is proportional to what? Now, my dear bacha log, you have to remember that we can calculate the formula for drift velocity of an electron using V is equal to U plus AT. Okay, here I will assume that after a collision, the average velocity of all electrons will become 0 and the acceleration of an electron is E by m. Because remember, beta, force on an electron will be equal to charge into electric field and acceleration will just be force by mass, which will just be E by m, which gives me acceleration as E by m, and time taken beta we will just take it as relaxation time tau. So drift velocity beta will just be E tau by m. Now mobility, my dear bacha log, is given by the formula mu is equal to drift velocity by electric field, the ratio of drift velocity divided by electric field, which beta when you calculate will just become E tau by m. So option A will be the correct answer. In this question, there is a current of 40 ampere in a wire of 10 raised power minus 6 meter square area of cross section. The number of free electrons per cubic meter is 10 raised power 29. Then we have to find the drift velocity. Beta, once again I will use the formula I is equal to NEAVD, which gives me beta Vd is equal to I divided by NEA. Substituting the values, beta, I will get 40 divided by 10 raised to the power 29 into 1.6 into 10 power minus 19 into area, which is 10 power minus 6. This will just be beta 40 divided by 1.6 into 10 raised to the power minus 29 plus 19 plus 6. That will be beta equal to 25 into 10 power minus 4 or 2.5 into 10 power minus 3 meters per second, which is option C. In this question, two wires of same material but of different diameters carry current I. If the ratio of their diameters is 2:1, then the corresponding ratio of their drift velocities will be what? Once again, beta, I will just write down that current is equal to NEAVD. So drift velocity beta will be equal to I divided by NEA. Now, my dear bacha log, both the wires have the same current. Both the wires are made up of same material, so they have the same value of N, and charge of electron is a universal constant. So all of these values beta are same for both the wires. Only the area of cross section will be different. Now beta, if I take the ratio V1 by V2, that will just become A2 by A1 while taking the ratio, because area here is in the denominator. It will be A2 by A1. When you divide, I, N and E will get cancelled out. Now area of cross section beta can just be written as pi r square, which can just be written as pi d square by 4, where d is the diameter. So beta, when you take the ratio of area of cross section, you have to remember that will be d2 square by d1 square. Pi and pi will get cancelled out and 4 and 4 will get cancelled out. So therefore beta, I can write down the ratio of drift velocities will be same as the ratio of diameters. Now beta, it is given to us in the question that d1 by d2 is equal to 2 by 1. So v1 by v2 beta will actually be 1 by 2 the whole square. That will just be equal to beta 1 by 4. So option D should be the correct answer. In this question beta, for a wire with a non-uniform cross section, we have to determine which of the following is uniform constant throughout the length of the wire. So beta, if you have a wire of a non-uniform cross section, what you have to understand is beta that there are certain things which will be constant everywhere. First of all, if you have a current I here, then the same current will also be there in this place beta. The current remains the same across the length of wire because the charge entering at this cross section beta should be same as the charge leaving this cross section. Okay, so the current will be same everywhere. But let's talk about everything else beta. Apart from that beta, the other constant N and E will also be same everywhere. N is number of free electrons per unit volume and E is charge of one electron. E has a constant value which is a universal constant, never changes, and N beta is what we call a material constant. So as long as beta the material of the wire remains the same, the value of N remains the same. The size does not matter for N. That is number of free electrons per unit volume. That's a constant value. It's a material constant. Now beta, I remains the same. But if you see beta, the formula for I is given by NEAVD. You will realize that drift velocity will be equal to I by NEA. Now here, since current N and E, all these three are constant and area is a variable beta, you have to realize that therefore drift velocity will also be a variable. Drift velocity will also be a variable. As area changes beta, drift velocity will also change. Now finally beta, let's talk about electric field. If you remember, there is a formula for drift velocity. It is given by the formula E tau by m. Now here beta, from this I can write down E is equal to m by E tau into Vd. Now you have to understand once again beta, m is the mass of the electron, which is equal to 9.1 into 10 raised to power minus 31 kg. Once again a universal constant, and time beta is relaxation time. Tau is relaxation time beta. It is once again a material constant and its value depends on the type of material and temperature. It does not depend on the area of cross section or the size of the material. It only depends on type of material and temperature. So this beta is also again going to be a material constant. Throughout the wire beta, it will have the same value. So once again, all of these are going to be constant, my dear bacha log, and drift velocity is a variable. So therefore beta, I will have to say that electric field is also a variable. You have to realize beta that in this case only the current will be constant, drift speed will be variable, and electric field will also be a variable. In this question, a potential difference is applied across the ends of a metallic wire. If the potential difference is doubled, then the drift velocity will be what? Now beta, remember I is equal to NEA Vd, which gives me Vd is equal to I divided by NEA. Also at the same time beta, using Ohm's law, V is equal to IR. So I is equal to V by R. If I substitute that here, this will just become V divided by NEA R. Now you have to realize beta that therefore the drift velocity is directly proportional to the potential difference. If the potential difference is doubled, then in that case, my dear bacha log, the drift velocity will also be doubled. So option A will be the correct answer. In the next question beta, a copper wire of length 1 meter and a radius 1 millimeter is joined in series with an iron wire of length 2 meter and radius 3 millimeter, and a current is passed through the wires. We have to calculate the ratio of current densities in copper and the iron wires. We have to calculate the ratio of the current densities beta in the copper and the iron wires. So beta, first let's say is the copper wire. First let's say is the copper wire, and then beta it is connected in series with an iron wire beta. Okay, the first one has a radius of 1 millimeter, the second one has a radius of 3 millimeter. Now my dear bachcha log, understand that when wires are connected in series, their current will be the same. So if the current is I through the first wire, then the current will be same I through the second wire as well. So the current density J1 beta will be equal to I by pi R1 square, and the current density J2 will be equal to I by area pi R2 square. Current density is current per unit area. Now if I take the ratio, my dear bachcha log, then the ratio of J1 by J2 will be R2 square by R1 square. That will beta just be 9 by 1. So option B will be the correct answer. In this question, the assertion says there is no current in the metals in the absence of electric field. And the reason says motions of free electrons is random. Now beta, first of all, this one is correct, because if beta there is no electric field, then the drift velocity of the electrons beta, which is E tau by m, will be equal to 0 since the electric field is 0. And beta, since the drift velocity is 0, then I beta will be equal to NEAVD will also be equal to 0. Now my dear bachcha log, in this case, what is Vd beta? Vd is the average velocity of all electrons. Now beta, in the absence of electric field, all electrons will definitely go in all random directions because there is no electric field to direct them, and therefore beta, the reason statement will also be true. And when beta, the motion is completely random, the average velocity should be 0. For random motion, average velocity of all electrons should be 0. So in this case, my dear bachcha log, both assertion and reason is true. And if you think about it, reason does correctly explain the assertion. Because of random motion, drift velocity will be 0. And therefore, my dear bachcha log, the current will be 0. In this question beta, the drift velocity of electron in a metallic wire will increase if the temperature will decrease if the temperature of the wire is increased. The reason is, on increasing the temperature, the conductivity of the metallic wire decreases. So my dear bachcha log, you have to remember that the resistivity of a wire, conductivity of a wire beta, the conductivity of a wire is given by the formula Ne square tau by m. Here beta, n is number of electrons per unit volume, E is charge of electron, tau is relaxation time, and m is mass of electron. Now you have to understand beta that if temperature is increased, then in that case my dear bachcha log, the relaxation time decreases because the electrons start moving faster, they start colliding faster with each other, therefore the time between two collisions decreases. And in that case my dear bachcha log, you can say that the conductivity of a metal definitely decreases. So the reason is correct, it is true. But beta, let's see if this tells us anything about the assertion. Now my dear bachcha log, if conductivity decreases, then you have to realize beta that the material becomes less conductive and therefore the current through the conductor will also decreases. Material becomes less conductive, resistance will increase and therefore the current will decrease. And my dear bachcha log, since current is given by the formula NEAVD, I can write down VD is equal to I by NEA. You have to realize beta that if current is decreasing, then we also have to realize that the drift velocity will also decrease. So as a direct consequence of conductivity decreasing beta, we can say that drift velocity will also decrease. So assertion is also true, and we can say that option A is the correct answer. Assertion, reason, both are true, and reason explains the assertion. In this question beta, assertion is that unit of mobility is meter square divided by volt per second. And the reason is drift velocity per unit electric field is called mobility of an electron. That is mu is equal to Vd by E. Now my dear bachcha log, you should understand that unit of drift velocity is nothing but meters per second. Now unit of electric field beta, electric field is written in two different ways. Electric field is Q into E is equal to force, which gives you E is equal to F by Q. So one of its unit will be Newton per coulomb. But also at the same time beta, you have to remember E is equal to negative of dV by dr. So using this formula, the unit of electric field will also be unit of dV, which is volt, and divided by unit of dr, which is meter. So unit of electric field will also be volt per meter. There are two possibilities. Now if I use this one and this one beta, then the unit of mobility will just be meters per second divided by volt per meter, which will just become beta meter square divided by volt into second. So yes, the reason is true. Yes, the assertion is also true, and as reason correctly explains assertion beta. In this question beta, we have to determine which of the following is an ohmic resistance. Beta, an ohmic resistance is a resistance which follows Ohm's law. Which follows Ohm's law beta is that essentially what does that mean, which follows Ohm's law? It is essentially a resistor for which V is proportional to I. And beta, if you see, only first option is showing that V is proportional to I, direct proportionality. So option A will be the correct answer. In this question, in the metallic wire, the ratio V by I is, we have to determine beta how does it depend on temperature. So my dear bachcha log, you should know that for metals the ratio V by I is actually the resistance R. And beta, this resistance R is dependent on temperature according to the formula R is equal to R naught into 1 plus alpha delta T. Essentially beta, if temperature increases my dear bachcha log, then in that case the resistance also increases, which means beta that the ratio V by I is going to increase because V by I is same as R. So my dear bachcha log, option B will be the correct answer. The ratio increases as the temperature rises. In this question, a wire 50 centimeter long and 1 millimeter square in cross section carries a current 4 ampere when connected to a 2 volt battery. We have to calculate the resistivity of the wire. So beta, first of all, we will use V is equal to IR to calculate the resistance. I will say 2 is equal to 4 into R, which gives me R is equal to half ohm. Next, my dear bachcha log, we will use the formula R is equal to rho L by A to calculate the resistivity. Here beta, R is half, resistivity rho, length is given as 50 centimeter, that is 0.5 meters, divided by area is given as 1 millimeter square, that is 1 into 10 power minus 6 meter square. Bacho, you have to remember, this is very very important beta, you have to remember that 1 millimeter is 10 power minus 3 meter, so 1 millimeter square will be 10 power minus 6 meter square. Okay, from this rho will just become beta half into 1 by 0.5 into 10 power minus 6, or you will get rho is equal to 1 into 10 power minus 6 ohm meter. So beta, option D will be the correct answer. In this question, my dear bachcha log, we have to calculate the relationship between current density and electric field. Better remember that V is equal to IR. Now also at the same time, my dear bachcha log, J is equal to I by A. So I can just write down I is equal to JA. Also better remember that V is equal to E into L, which gives me beta, V is equal to E into L. And finally beta, remember R is equal to rho L by A. If I substitute this and this, all the three beta into this relation, I will get EL is equal to JA into rho L by A. Now my dear bachcha log, if you see, AA will get cancelled out, LL will get cancelled out, and I will just get the formula E is equal to J rho. So essentially E is directly proportional to J. Option B will be the correct answer. In this question, the voltage V and current I graph for a conductor at two temperatures T1 and T2 are shown in the figure. The relation between T1 and T2 is what? Now beta, here V versus I graph is given. So if I take the tan theta values beta, understand that here tan theta values will just be equal to the ratio of V by I, which will just be resistance R. Now as we can clearly see beta, theta 1 is bigger than theta 2 from the diagram. Therefore tan theta 1 will also be bigger than tan theta 2, which means R1 will be bigger than R2. Now beta, if you guys know that for ohmic resistors, for metals, if temperature increases, then in that case resistance also increases, which means beta that therefore the temperature T1 will also be bigger than temperature T2. So option A will be the correct answer. In this question, the IV characteristic of a copper wire of length L and area of cross section A is shown in the figure. the slope of the curve becomes what if the temperature or dimensions are changed, my dear bachcha log. So understand that in this case the value of tan theta will be equal to I by V, which will be inverse of a resistance beta. Now, first of all, if temperature is increased, then in that case beta resistance value will increase, and therefore beta tan theta value will decrease. So at higher temperature the slope will actually be less, so option A is false. Next, more if a wire of steel of a same dimension is used. Now here beta, what you have to remember is that copper is one of the best conductors out there. The only conductor which is better than copper is steel. Is silver. Copper is one of the best conductors beta. The only one better is silver. Steel on the other hand beta is not a very good conductor compared to copper. So here my dear bachcha log, what you have to remember is that resistivity of steel is much bigger than resistivity of copper. This is somewhere around 9.9 into 10 power minus 8 ohm meter, and this is somewhere around 1.7 into 10 power minus 8 ohm meter. So here if we change beta the wire to a steel wire, then in that case for the steel wire the resistance will be equal to more, and therefore my dear bachcha log the value of tan theta will be less because the resistance is in denominator. So this statement is also false. Now next is more if the length of the wire is increased. Now in this case my dear bachcha log, remember R is equal to rho L by A. So if length is increased my dear bachcha log, then in that case the value of resistance will become more, and in that case my dear bachcha log tan theta value will become less. So option C will also be false, but we know that option D will be true, so option D will be the correct answer. Very, very good. In this question, assertion says resistance of a conductor depends on the potential difference applied across it. The reason says the resistance does not depend upon the material of a conductor and the dimensions of a conductor. Beta, in this case the assertion first of all is false my dear bachcha log. Remember V is directly proportional to I. If I remove the proportionality, I have to add a constant. Here R is the constant of proportionality. What this means is my dear bachcha log that R is independent of V and I. For that equation R is the constant of proportionality. So assertion is false. R beta actually depends on two things. It depends on beta the dimensions of a conductor, length and area, and it depends on the material of the conductor, the resistivity of a material. So reason is also false beta, and therefore option D will be the correct answer. In this question beta, we have to calculate which of the following has a negative temperature coefficient of resistance. So beta, understand that brass, copper and iron, all of them are metals, and for metals beta, alpha is a positive quantity. Temperature coefficient of resistance is a positive quantity. But on the other hand beta, this silicon right here is a semiconductor, and beta, for semiconductors the value of temperature coefficient of resistance is negative, so option D would be the correct answer here. In this question beta, the electrical resistivity of a material is proportional to length, proportional to area of cross section, inversely proportional to length, neither depends on length nor the area of cross section. Now beta, remember that R is equal to rho L by A. Here beta, R value depends on both length and area. But beta, rho, which is the resistivity, is actually a material property. Its value, my dear bachcha log, depends only on the type of material and the temperature of the material. So it is independent of length and area. So oh beta, option A and B are both incorrect. Option C is also incorrect. It is option D which is the correct answer. It is independent of both area and length. Here we have to calculate which of the following is the best conductor of electricity. So beta, as I told you, the best conductor of electricity, my dear bachcha log, is silver, which has the minimum resistivity. This one is the best. And beta, the second best is copper and the third best is gold. So out of all the options given to us, my dear bachcha look, platinum by the way comes way below. Platinum is actually even after steel, and silicon to beta is a semiconductor, so definitely not a very good conductor. So the best conductor out of all the four options given to us, it will be copper.